Hello everyone, we are here to take up a few concept videos related to force and laws of motion, and the basis or the reference for these videos would be Eduwise's CBSE Physics for Class 9th written by me, and in this particular video we are going to look at the different concepts that are actually covered in the NCERT syllabus for Class 9th. So let's start with it, and I hope that you gain by the end of it. What essentially constitutes a force? Any activity that involves a pull or a push is in layman terms called a force. These activities of pull or push could involve lifting, you lift anything, or stretching, hitting, pressing, twisting. All these activities that you can talk of, they involve pull or push, and they constitute what is in scientific terms called a force. In the image that you can see here, you can see that a boy is pushing a pram. When he is pushing a pram, he is applying a force on the pram and it is causing it to move. In the next image, you can see that a girl is playing billiards. Now when she hits the ball with the stick, she is actually pushing the ball to go to the nearest hole that she wants to, the nearest pocket. In the third image, you have a person pulling out the string from a lamp. So when he pulls the string, the bulb lights up. So he is pulling it and applying a force for the lamp to actually perform a specific action of lighting up. In the next image, you see that the boy is bending down to lift something up. Now that is pulling something. He is lifting or pulling something. In the next image, you see that a boy is running with a car with a string in his hand, and the string's one end is tied to the car. So he is essentially pulling the car with the help of that attached spring. That also involves force. So various activities that you can see in this image, they basically are pulls or pushes, and they all involve a factor that's called force. Now when you apply a force, there is a specific strength that you are applying on an object, right? When you are pushing a pram, you are applying your strength on the pram to move it. So force essentially involves magnitude. When you apply that force on the pram is going to move. Now when the pram is going to move, there is a sense of direction. When you apply a force in a particular direction, the object would move or would tend to move towards a particular direction. Hence, this particular quantity, the force, would also involve direction in it. Hence, if you have read the first chapter, it is a vector quantity, because any quantity, any physical quantity that involves magnitude as well as direction is called a vector quantity. So force is a vector quantity. Now if you want to define it specifically in scientific terms, we call force as the cause that changes the state of rest or of uniform motion of a body, or which changes or tends to change the shape, size or direction of a moving body. So whenever you apply a force on a body which is kept at rest, the application of force is going to tend to change the state of rest. So when you push something at rest, it may move. If it is already moving, then it may bring about a change in its state of motion. Or a stationary object, if you apply a force, for example, you can also deform. You just have a piece of dough that you keep here, and you apply a force on it. What will it do? It won't cause it to move, it will just cause it to deform, it will change its shape. So application of force can involve change in the state of rest or state of uniform motion, or it would also change or tend to change the shape or size or direction of the body. So this is what is the definition of force that we have to study. Now forces, the next topic that we get on to is balanced and unbalanced forces. So what are balanced and unbalanced forces? Any body, it's not necessary that any body would be acted upon by just a single force. There could be n number of forces that could be acting on a body, and they could act in various directions. So effectively, when you have an object, like in the image that you see in the first figure, underneath the balanced forces, you can see that there is an object, there is a block that's kept on the table, and you have two forces of equal magnitude. And what is the magnitude? Two forces of equal magnitude of 60 Newton, but acting in opposite directions, are applied on that body. Now what will happen to that body? the net effect of one force will be cancelled out by the action of the other force. So effectively a 60 Newton force going towards the right cancels out the effect of a 60 Newton force acting exactly opposite to it. Hence the resultant force in that case would be 0. 60 and 60 would cancel each other out and the resultant would be 0. So in this case the object, if it is kept at rest, it will stay at rest, and if it is moving with some velocity, it will continue to move with that constant velocity, because there is no force, net force acting on it. So in case the resultant force becomes 0, that is when the effect of all the forces cancel each other out, then we say that the forces are balanced. In the next image that in the next figure that you can see, which is unbalanced forces, what happens is that in this case an object can be acted upon by various number of forces or forces of different magnitudes, and then we calculate the resultant. For example, in the given example, we have a force of 20 Newton acting from one side and a force of 60 Newton acting from the other. Now what happens to this particular object? You have a 20 Newton force acting on one side and a 60 Newton force acting on the other side. So the net effect of the two forces will be 40 Newton of force acting in the direction of the greater force. So effectively the resultant force will be 40 Newtons and its direction will be in the direction of the greater force. Note here that the case that we are discussing here is of forces acting exactly in opposite directions. They might not be of equal magnitude, but they are in exactly opposite directions. So when they are in exactly opposite directions, we can say with certainty that the direction of the resultant force will be in the direction of the greater force. And what will its magnitude be? Its magnitude will be the net effect, or after cancelling out the effect of the smaller force, you just get a net resultant force of 40 Newton, as you can see in the image there. So what we see here is that opposite forces, they cancel the effect of each other, and when balanced, the net force on a body is taken to be 0, and a resultant force is the net force acting on a body that is acted upon by several individual forces. So this is what we have to study about balanced and unbalanced.